So moving right along, our next speaker is a dear friend and another absolutely obsessed sunfish researcher, sunfishophile, sunfishinado, as we call them. Marianne Nyegaard, hello, coming to us all the way from New Zealand.
Kia ora and good morning from New Zealand, where it is 5:30 in the morning, and I have just absolutely loved watching the first part of this symposium, so it was well worth getting up at 4:45.
You're a diehard. You're a diehard. Absolutely always going the extra mile. That's something everyone should know. Marianne Nyegaard goes the extra mile. Yeah. So Marianne actually did her whole PhD on sunfish. And I think you had wanted to do it on the sunfish in Indonesia, but they were such a tangle in terms of the taxonomy that sort of sucked you in.
Well, I always entertain with how I didn't get to more than the title of my thesis, and then I ran into problems because I couldn't. First, I thought they were Mola, and then they weren't, and then when I started looking, it was just all a mess. And then doing genetics, of course, there was a third species and all of that. So yes, it was like a massive detour, taxonomic detour that was absolutely delightful. And of course, I met Itsuru through this venture, which has just been an absolute delight. Yeah, so very fun.
Yeah, and a new species to boot.
Yeah,
more than 100 years. So it's so exciting. So exciting.
So I just want to do a shout out to Mola tecta, because I think the sunfishes are awesome, but that is just a little bit most awesome.
Yeah, even more awesome is that you thought you had it in just your southern hemisphere neck of the world, but no, it's come up and it's popped up on our shores here in Central California. So more on that. You'll be talking to us more on that as well. And that's what you're going to be talking to us on this, because you're going to be giving a couple talks during the day on fisheries later today, but your first one is going to be on Mola tecta. So so let's hand it over to you. We'll have time for some questions afterwards, but just say so you are you did get your PhD at Murdoch University on Mola Mola tecta and there be giants, and yeah, so you'll give us insight into Mola tecta, and the story is so much more than people know. This is late breaking new information.
Thank you so much, Tierney, for that introduction. So can you all see my screen? I'm on. All right. So yes. So thank you, everyone who has tuned into this presentation about Mola tecta surfacing in the Californian current system. And now this is not my own work only. I worked closely with Jackie Gildering, Tuomo Wetlassen, and of course Tierney Tice on this. And the presentation will really focus on citizen science in the context of sunfishes. So the whole study goes back to 2017, where we described this new species, Mola tecta, from New Zealand. And we called it hoodwinker sunfish as a nod to its ability to hide in plain sight right in front of everybody for all this time, despite growing to nearly 2.5 meters in length. It was the third species in the Mola genus and the fifth in the Molidae family, at least as the taxonomy stands now. So when we described it, we had most of our information from Southeast Australia and New Zealand, and we had lots of genetics and specimens and images. But we also had evidence of Mola tecta of South Africa and also from the coast of Chile. So we kind of eyeballed this, and the map you see here is sea surface temperatures like an average. So red is warm, blue is cold, and you can see the temperatures down here. So we kind of eyeballed it going, wow, this species seems to be liking this kind of temperature down here. So it's probably a southern temperate hemisphere species, and it's probably restricted to the northern hemisphere by all this warm water. And we did search high and low for evidence of it elsewhere and didn't really find it, except there was one from 1889 that had stranded on the Dutch coast, which is actually still in existence. And at the time it was in storage behind a giraffe at the museum up in Holland, but we did manage to get some pictures of it, and we're pretty certain that's Mola tecta, but we considered it like a freak coincidence or like a lost fish. And this was consistent with some other work I did during my PhD, where I sampled genetic samples from sunfish caught as bycatch in the longline fishery. And we found that we had 4 species in the fishery. And you can see Mola alexandrini here is the triangle. It's the most common one in the sort of the subtropical warm temperate band here, whereas further north we have Masturas lanceolatus, which is the green triangles here. And then further south is where we find Mola tecta. So this is really Mola tecta country down here. And as you can see, we have the odd mola here. And when we looked at the sea surface temperature that was associated with the fish at the time of sampling, and this is only live specimens we did this for, we could see that Mola tecta really had a was associated with significantly lower temperatures than Mola alexandrini and Masturas. So this kind of all added up to this being a temperate southern hemisphere species. So I was more than a little surprised when already in 2019, a Mola tecta washed up on the beach in California. And this was, of course, this came to light through citizen science, through iNaturalist, where Tom Turner over in Santa Barbara posted or uploaded his sighting. And one of my colleagues spotted this, alerted me and said, hey, is this a hoodwinker? And we did manage to confirm that genetically and through pictures. And I was very surprised and didn't quite know what to make of this. Was this an extreme coincidence that it was spotted so soon after description? Was it kind of a freak incident like in 1889, or was it something else? But soon afterwards, during 2009, more reports started to come out of California all the way up to Alaska of this fish. And here's one. This is from Monterey Bay. This was reported to me by Patrick Webster, and he was really pivotal in the beginning to alert me to these sightings. And that really made me think, well, exactly how common are these fish over there? And I thought that this was a good citizen science project because lots of people photograph molas over in California, upload them. Of course, when you use citizen science, you don't really have a good idea of the effort. So communality is a difficult thing with citizen science. So I thought, well, maybe we can look at it relative to Mola, a bit like I had done in Australia, looking at the relative occurrence, because the effort is presumably the same. People don't preferentially photograph one species of sunfish over the other, especially because they look so similar and most people can't tell them apart. But that meant that we had to collate a database of all Mola observations from California all the way up to Alaska. And iNaturalist is a brilliant place to start. And if you don't know of it, it's a great platform for citizen science. Anyone can go in there, create a profile, and log their observations of any organism. And together, we're building this massive understanding of where species occur across the planet. And this is the Mola sightings as of a few days ago, and there's a lot more than back in 2019. But still, we can see there's a big gap here up north where we do know the hoodwinker occurs. So having dabbled in citizen science before through my project up in Bali called Match My Mola, where we do photo identification of individual sunfish, I know that to succeed in citizen science, you really have to have a local relevance. You have to have a local presence, and you have to have a local network. And I get around that in Bali by collaborating with Jennifer Kami, who's my dear friend. So shout out to her if you're watching, Jenny. So I just had a problem here. This is me down here, and this is the study area up here. So there was literally an ocean in between us. So fast forward to March 2020, when the world started to lock down for COVID, including here in New Zealand. And I thought it was a good time to start reaching out to people. And in reaching out, I was so lucky to come across Jackie Hildering, based on Vancouver Island in British Columbia in Canada. She is part of the Marine Education and Research Society and is also behind the Marine Detective. And she is an ocean lover and enthusiast, and she is right into citizen science, communication, and outreach. And she was keen to join the project, which I'm so thankful for. Of course, there is Tierney Tice, who needs no further introduction here, but and as many of you may know, she has run a citizen science program for years, logging sunfish sightings right across the entire world. And of course, she was right in the middle of the action in amongst it there in California, and luckily she agreed to join the study as well. And through her, I was lucky enough to meet Tuomo Wet-Larsen, and you will understand why that was lucky a little bit further into the presentation. So data collection really started through outreach seriously in 2020, and we've done it for a little over a year now, but it has vamped up significantly in the last couple of months. And it's done primarily in British Columbia through MERS, through Jackie Hildering, who's very active on social media, and also has an extensive local network. The media has also helped us here. They've run a couple of stories about us, and getting media exposure is absolutely brilliant in citizen science. So it has been so successful that we're expanding it to California, Oregon, Washington State, and Alaska, and that's primarily Tor who's spearheading that. And on top of that, we're also actively data mining the internet. So we have a Surveymonkey approach where we have a form, people can fill it in and upload their sightings, and this is great. We get the data in a neat format just like we want. But of course, that's not how citizen science works in reality, because everyone has their own preferred platform and ways of communicating and submitting photos. So we're dealing with a source that's really diverse, and we have to do a lot of communication in this project. So to streamline this into a curated photo database that's verified, so we have trust in the data, is a significant effort. And this is where Tor comes in. He's been an absolute Superman champion here, taking the lead here, and the number of hours he has spent on this is phenomenal. So thank you, Tor. At the moment, we have well over 800 observations and much more than 2,000 photos and pieces of footage. And the challenge now is to species identify the molas from these photos. And as you guys touched upon before, that can be a challenge. So our photos broadly fall into 4 categories, and that is photos where we can't really see the fish. We might have a fin sticking out of the water. We might be able to see the fish, but the species characteristics are ambiguous. Then we have a category where there are indications of characteristics, and we have a strong subjective impression of what the species is. And then we have the best category, of course, where the characteristics are super clear and consistent, and we can for sure tell what it is. And this is a gradient, of course. And so to try and take some of the ambiguity out of this and the subjectivity, we're attempting to divide it into these categories here, where up here we really can't say what it is. But once we get down here, we operate with a suspected ID, and then we have a certain ID. And the reason is that at this stage of the game, we do not know whether one species is easier to identify than the others from pictures, so that we preferentially identify one of them more than the other. So we really need to look at these 2 categories very carefully to make sure that our data set is not biased. Now, so how do you pick a hoodwinker? I thought I would just quickly go through its main characteristics. And so here we have a Mola tecta and a Mola. And when you deal with species IDs from photos, you need a combination of traits. You never rely on one trait alone. So you need a combination, and everything needs to be consistent, really. So body form, when looking for an oval shape, elongated, we're looking for a flat head, no head bump whatsoever, rounded nose, no extension at all. Rounded chin, no indication of a head bump at all. The body needs to be smooth with no bulging keels or any, it's a very sleek and good looking sunfish, I think. It does have a little kind of an eyebrow up here, a little kind of extension out here. Down the clavus end, if you draw a line from there to there, the clavus needs to be relatively narrow. It has a smooth edge and it has no more than 8 ossicles. So those are the little bony formations in the edge there. The smooth clavus band that allows the sunfish to move the clavus from side to side is relatively narrow and very well defined, and it has a backfold there that allows the sunfish to move the clavus, the 2 pieces opposite to each other. And if we go up to the Mola here, we can see that superficially it actually looks pretty much like a hoodwinker. It is elongated, it doesn't have a head bump, it has a rounded snout, no chin. But when we get to the back here, we can see the clavus is broader and the smooth band is much broader and it's messier here. So even though we can't see waves clearly, it is wavy or it's messy, it's not a smooth one. But most importantly, we can see these bulging keels here. So this is bulging out. And also these horizontal skin wrinkles are characteristics of Mola, even though it's not at the moment described in the literature as a taxonomic characteristics. This, when you see Mola and these wrinkles, if you see wrinkles, it's not a Mola tecta. So I can't stress enough how important it is to look for a combination of traits, so not just one. Here we have a bit, 2 pictures that are clearer perhaps. This is Mola of 2 meters, that's Tierney dissected with this tiny little camping knife here. And here is a Mola tecta that Tor went and sampled. And so we can see here, this is a Mola with a clear chin bump. We can see the waves here at the margin, and we can see the clavus band here is broad, and we can see indications of these wrinkles, these skin wrinkles. We can't see the head bump or the upper part of the head here, so we can't really tell what's going on with the nose shape. Here's tecta, very rounded here, very smooth clavus here. The band is there, the backfold is there. The ossicles that you can actually see are small, and we've got an indentation just here where the backfold is, and no bulging keel. So these can actually be identified for sure from photos. If you zoom in on the clavus, it's even clearer. Mola here with the waves, and if you know what you're looking for, you can actually see ossification around the edge here, which is typical of Mola as well. You can see a large ossicle. The ossicles here are smaller. You can see the indentation and the backfold, and the skin here of Mola is very characteristic. It looks like droplets. The denticles of the scales are very large. In sunfish, size matters, as Sura touched upon. When you identify them as when they're little, below 50 to 70 centimeters, they can be really, really hard to pick unless you have the actual specimen there. When they get older, we can much better see who they are. Mola tecta is probably the one that changes the least with growth. It looks pretty much like it does when it's little. In citizen science, you don't often have size estimates, so we need to gauge this because it's important that we know what traits we can expect to see on the photo. And here we have great help. Tanabe and Davenport have done this good piece of work here where they have looked at the aspect ratio of the dorsal and anal fins of sunfish of different sizes. And we can see as the sunfish grows, the aspect ratio changes and the fins become broader relative to height. And here are 2 examples. I think this is Mola, but again, it's hard to say. This is definitely, and we can see this is a relatively small sunfish because the fins are small, and here these are broad, so this is a large sunfish. So this tells us what can we expect to see. Now, I want to touch upon something else that is a potential bias in citizen science. And in this particular case, when we look at the ratio of Mola tecta observations to Mola, it's important that we get a representative of what's actually out there. But we don't know at this point if there is a difference in the likelihood of stranding between these 2 species. if they occupy the sea surface at the same frequency, if they use the reefs the same, and if they interact with fishing gear the same. So this can actually lead to bias in photos that we get from the beach or the shore, from the snorkelers, boaters, aerial surveys, the scuba divers, and surveys. So this is something else that we really need to be aware of. Now, I want to round it up here with some preliminary thoughts. We haven't, as I said, we're mid-study, so we don't have results yet, but we can report we have hoodwinkers from California all the way to North Alaska, Kodiak Island. And we can now say that this is not a freak occurrence. This is not just one lost fish, and we may be looking at a natural range extinction. But of course, this begs the question, how do they cross over from the cold water down here in the Humboldt Current along the coast of Chile and come up into the Californian system? And here it's important to remember that the ocean isn't static, as we all know, and the temperature changes seasonally, but also with climate phenomenon such as the ENSO oscillation that brings us the La Nina and El Nino events. And during La Nina, which is this here, so again, this is sea surface temperatures, red is warm, blue is cold, we can see that the sea surface temperature between here is much lower than during, for example, El Nino years. So it's possible that this area kind of opens up once in a while for these fish so that they can cross over the equator during cold phases. But that would mean there is some degree of connectivity here. And of course, that would be very interesting to examine with genetics. But we're on an uphill battle here. We've got two samples so far from California, and there is very little genetic information from this area. So it'll be some years, I think, before we can answer that question. Right, that brings me to the end of the talk. And I just want to acknowledge again, Jackie, Tierney, and Tor for all the work and help they have done, and a few people here who have been absolutely pivotal in spotting the hoodwinker and spotting reports subsequently. And of course, to the countless people out there and citizen scientists who have, responded to our call and submitted their photos. If any of you guys are watching, thank you so very much. And that is time for questions now. And the very last thing is I just want to say our survey is still open. If you have any observations from the Pacific Northwest, California to Alaska, please submit them. Here is the website. And that's all for me. Thank you so much for listening, and please ask any questions that you may have.
Wow. Well, thank you, Marianne. This is so exciting. It's so exciting that it's shown up here in California and all the way up to Alaska. And I think, Jonathan, you had mentioned how important it is to get people's sightings out there. iNaturalist, I'm glad iNaturalist is mentioned iNaturalist because it's such a great resource. I mean, I started the oceansunfish.org sighting, but it's hard to keep up with all that. And iNaturalist has such a great established infrastructure taken over by Cal Academy of Sciences, and it's just such a terrific resource. So big kudos to iNaturalist for being there. Yeah, and I definitely wanted to just say a quick shout out to Tor as well. Tor lives here. I met Tor when he was in high school, and he was fascinated by ocean sunfish. This was years ago, and then since I saw him again at Scripps not so long ago, and he really helped me in the initial stages of the book, and then later on. So he's really been in the thick of things with the book as well. So a shout out to Tor. I hope you're listening. So.
That's good. Could I chip in with one quick question on first of all, very nice to meet you. I've known your name for years. We've never met. How are you?
Same. Nice to meet you.
Absolutely. No, I changed my kind of relationship with sea surface temperature this year, so it's not a difficult question. But we got really curveballed by some of our work on a different species, basking sharks. So we had a bunch that overwintered all the time in Scotland and a bunch that disappeared off to Africa. And actually, we were always looking at basking sharks two-dimensionally, and so it was like, hey, this is a seasonal movement moving down with the temperature. we actually, when we managed to crack the diameter on the sort of PSAT satellite tags, we found that the sharks off Africa actually experience colder winter temperatures than the ones that overwintered in Scotland. So I wondered if, just from your gut, if you had any idea, could there be any weird curveballs with sea surface temperature for ocean sunfish? Do you think it is as simple as we maybe think, sort of up and down, or could there be deep and coming up again as well?
Oh, that is such an interesting question, because you're right. You know, we see the ocean as two-dimensional. I think crossing the equator for a hoodwinker, seeing how we just don't see them in Australia very far north. They seem to be so restricted down to the colder water, and that there must be something that that keeps them there. And so even if they could kind of dive underneath the warm water and then surface up in California, it's a long way to travel.
Huge.
And how would they know that they would meet a good system? Because I guess once they're there, it's a great place for them to be. But how, for the individual off Chile, for example, if this is what happens, how does it sort of start heading north in good faith and diving under this one? I really don't know, but I would. Somebody said, shouldn't we tag some? And it would be lovely, but how we get to tag some that will do the crossing, I don't know. We need a lot of funding to tag them all.
Exactly.
So I think genetics is probably the best place to start to try and see if there is connectivity. Yeah. So at the moment, we have just analyzed the one sample, and I can say preliminary analysis shows that it's, you know, we can't see the difference between that and the ones here in New Zealand.
So, which is really interesting.
Oh, yeah. And I mean, so it's very, very interesting. Yeah.
Yeah. But we do know that, you know, sunfish have a pretty high thermal range. You know, some of the molas that we were satellite tagging off Japan went down to temperatures of 1.8 C and then up to 20 degrees C. So, I mean, within the course of a dive, so that, you know, they can tolerate these large thermal ranges, which is pretty interesting.
There's something metabolic in that, whether at colder temperatures you get enough bang for your buck when you're eating basically cold water, whether you actually get enough return, you know, from what you're actually doing. And I'm not going to hog the floor. I'm just fascinated by what you said, because when you get these random movements, I wonder if they are directional, if that's our bias. We see some fish going somewhere. It's the same as the basking sharks. I'm starting to think, actually, it's just lots of small decisions added together, and then you end up somewhere. We just have this human perspective, like if you're traveling, you must have a destination in mind. You know, so I wonder if that's in there as well. Shut up. But
yeah,
superb talk.
I can't wait to talk more about this, because like I don't have the answer to what the Mola tectas are doing up in the system of near UTN, but it's very funny we're linked this way.
I know. It's so funny. It's so funny. It's like the fish is like, well, if you can't be together, I'll bring you together.
Yeah.
That's right. Yeah, our little COVID ambassador there. Well, we could talk forever on this one subject, but